Hi, I'm Daria.
And I'm Kelsey, and in this experiment we're lighting a $1 bill on fire.
So in this experiment you need alcohol, water, salt, newspapers to cover the area you're using, a $1 bill, tongs, and something to light it on fire with. Plus we have a glass of water for safety. So what you do is you soak the dollar bill in the solution.
And add salt.
Yeah, you add a little bit of salt. Which,
and you really soak it in there. Make sure it's
pretty
wet.
Soaked.
The solution.
Okay, that's good. And then you move it very, very far away.
Solution away from where you're going to be working.
And then, ready for this, Kelsey?
Ready. Fire!
See? It doesn't even light on fire.
What?
How can that be? See, good as new. Just a little wet.
Perfectly unharmed. Just wet.
Okay, so in this experiment happens because fire is a chemical reaction called combustion. In this case, the reaction occurs between alcohol and oxygen in the air and produces light, heat, carbon dioxide, and water. The dollar bill is more like cloth than paper, so it's a bit harder to burn anyways. It soaks up the water pretty well. When the bill is soaked in the solution, the alcohol has a higher vapor pressure than the water and is located mainly on the outside of the bill. Compounds with high vapor pressures are volatile and form a high concentration of vapor above the liquid. When you light the $1 bill with a match, or with that,
the lighter,
the alcohol is what burns, not the water. Also, alcohol burns at a low relative temperature, which means the temperature at which the alcohol burns is not high enough to evaporate the water out of the bill. Water has an unusually high specific heat too. That means it will change its temperature less when it absorbs or loses a given amount of heat. Thus, the bill remains wet and is not able to catch fire on its own. And the salt in the solution just adds color and is used for effect. And that's our MOS.